Okay, so hello everybody. I think I can go ahead and start. My name is Sana Awar and I will be your host this evening. So I'm the Product Marketing Engineer of the Data Center Test Solutions Business Unit in MultiLane. Thank you so much for attending this webinar, which we titled Streamlining CMIS Testing, a deep dive into interoperability validation. So for those of you who don't know MultiLane, we are a test equipment vendor. So we make compliance boards, we make active and passive loopbacks, as well as bit error rate testers and sampling oscilloscopes. Being a test equipment vendor, we've worked very closely with the module vendors and switch vendors alike. So we've been on the front line of our customer side and seen the real issues that come up in data center and lab environments. We've noticed that a big gap that we have in the industry has to do with the process of CMIS testing or interoperability validation testing. As the current procedure is very time-consuming, it's prone to a high risk of error, it's manual, and it requires a deep understanding of the CMIS standard. So we thought, how about a tool or a solution to automate all those tests that are required to validate CMIS implementation or to validate the full system interoperability. So a little bit on CMIS for those of you that are fairly new to it. CMIS is the Common Management Interface Specification. It's the universal playbook for interoperability of all Ethernet interconnects. So throughout the webinar, we're going to go into a little bit more detail of what CMIS is, why we use it, who uses it, and then we are going to go over the solution we propose, which is the hardware tool you see here, and we call it Nexus, before going into some examples and applications that we have seen time in at our customer's side, which we have replicated here and showing you guys the solution to it through Nexus. So this is really for you, for the firmware engineers, for the test and validation engineers, for the field application engineers and the team leaders to show you guys that spending hours upon hours validating CMIS or all the frustration that goes into debugging your system are really a thing of the past. So it's time for a new era when it comes to testing CMIS. So what is CMIS? So this is CMIS as per OIF, the Optical Internet Working Forum. Big shout out to the OIF. We are proud members of the OIF. We are currently preparing some really cool demonstrations for OFC. So CMIS, again, is the Common Management Interface Specification. It is really the universal language for all data center interconnects. So it's a language that modules and hosts use to communicate with one another. CMIS can be implemented on any type of pluggable, be it an optical transceiver or an active cable, and it's also implemented on the host side, so on servers, on routers, or on line cards and switches. Its goal is to really enable interoperability in data centers or lab environments. Over the past few years, interoperability has gotten more and more complex with the increase of data rates. Some features that are at the core of CMIS really aim to smooth interoperability or to enable interoperability, and some of these features are familiar to a lot of us in the industry, like access to a CMIS compliance module memory to which the host can read from or write to, or like a series of state machine tests to validate that your module is transitioning from one state to another, or that you're able to bring up your module with no interruption. And then we also have access to low-speed signals, which really validate the communication between host and module. So this, again, is a CMIS timeline as per the Optical Internet Working Forum. So as you can see, it's really evolved over the past 5 or 6 years. So the initial release of CMIS 3.0 was at 128 pages. And the most recent release of CMIS 5.2 is almost at 350 pages. So the number of standards have more than doubled, but the increase of these standards really aim to simplify or to enable interoperability. And these are some of the updates that have been worked on over the past few years. So today's webinar will focus on CMIS 5.0 because it's what we currently support. It's what we base the webinar on, which includes features like common data block management for firmware upgrades or access to I2C communication and analysis, as well as state machine tests. More recently, CMIS has evolved to support coherent modules. So again, CMIS has increased in standards or in pages of documentation to really account for the increase of variety of modules that we're seeing in the industry. So I'm going to go ahead and introduce Nexus to you guys. So we're going to start by introducing the solution before showing you how we really use it to solve some real life issues or some issues that are really interrupting the workflow. So Nexus is a hardware tool which sits between host and module. It's form factor agnostic. So here what you see in front of you is the OSFP Nexus. And it can be used solely as a hardware tool. So here you have access to the low-speed signals through a front probing interface. And you also have a dip switch, which allows for internal or external I2C source. So there is also two forms of cooling for Nexus. Usually when we want to use a high power module, so modules that dissipate 30 watts, basically modules of modern day data centers, we recommend a fan fixture upon Nexus. Otherwise, we rely on the host intrinsic cooling. Now, for more advanced testing, for really a full interoperability or a full CMIS implementation validation test, we have a very comprehensive user interface, which you have access to a USB interface on the hardware itself. When you have access to the GUI, you will have access to tests like state machine tests or to CDB or to monitoring interface or to access to the I2C communication, as well as capturing I2C packets and analyzing those. Why Nexus is really the ideal tool to sit between host and module and debug the module side as well as the host side, because Nexus has the ability to operate in 3 modes. So when Nexus operates in initiator mode, it acts as a host, effectively disregarding whatever it's plugged into and debugging everything on the module side. When Nexus is in bypass mode, it really sits between host and module and observes or taps into the communication between host and module. It sniffs the communication and has the capability to analyze it. When Nexus is in target mode, Nexus disregards whatever is plugged into it, effectively acting as a module itself and allowing you to debug everything on the host side. So I really wanted to go over this at first because we will be using this particular slide as a point of reference throughout the whole webinar. So I like to divide the CMIS implementation validation or interoperability validation procedure, testing procedure into 3 categories. So we have debugging and measurement, we have I2C access and analysis, and finally we have CMIS implementation validation. So debugging is really part of our daily lives as engineers. It's very time consuming, it's very detail oriented, and it's prone to a high risk of errors. Additionally, to debugging, just debugging, we have to generate test reports and present them, and really they have to be so cut, clear, and neat and organized, which we also tackle in solving. Next, we have I2C access and analysis. So validating the communication between host and module is one thing, but then taking a deeper dive into the I2C protocol itself and testing that is a completely different story. And validating CMIS implementation is simply the most time-consuming part of the whole process, and if I may, it's also the most frustrating part of the whole process. It currently requires a deep understanding of the CMIS specs. So I'm really excited to show you guys all these categories or all these applications through a different screen recordings. So whatever videos you see were pre-recorded. And yeah, I'm just going to explain each application through that. Now, before I move on, for all the attendees that are here, I would like to say that should you guys have any questions, please go ahead and post those on the Q&A part of the webinar. We have a team that is ready and dedicated to answer those questions before we get to the end of the webinar. Which, of course, upon the end of the webinar, I will also open the floor for questions and answers. So I'm going to explain to you guys the setup that I used to do the screen recording. So I had Nexus plugged into a MultiLane module compliance board, which is a CMIS compliant host interface. And then I had a CMIS compliant transceiver plugged into Nexus. Now I wanted to show you this to show you that Nexus supports 800 gig tracer. And so it allows for the passage of high-speed signals with no interruption whatsoever. And the loss is optimized for 800 gig. And then we also have diagnostic capabilities on the low-speed signals, also allowing you to tap into those with no interruption from Nexus whatsoever. So first, we're going to start with Nexus to validate CMIS implementation. So CMIS implementation is the most time-consuming part of the design process. This is for those of us who sit in the lab or sit on our desks and validate our module memory register by register against CMIS standards. So this is somewhat frustrating, and I want to show you guys how we automated this whole process. Now, validating CMIS implementation goes beyond just validating the CMIS memory map, but it also goes to validate that your host is able to read from or write to your module memory map. And then here we validate your CMIS compliant module memory map. So here I'm going to go over them briefly, and then I have a screen recording where I will focus on each tab. So here we have a tab called MSA validation, through which we implemented a CMIS register sweep, which allows you to validate the module memory in minutes against CMIS standards. And then we have module emulation. So this is to validate the host side of things, to validate that your host is effectively reading from or writing to the module memory with no issue whatsoever. So this goes to validate host routines and eliminating issues that may come from the host in question. And then we have control signals access. So this is a core feature of CMIS. We need to make sure that once the host sends a command about any control signal, the module is receiving that. And then we have state machine tests to validate that my module is going from low power to high power with no interruption. And if there is an interruption, why or when? And then we have, which I'm very excited to show you guys, access to apps and codes, because I know that this has been really needed and we've been asked about this a lot over the past year from people in the industry. So I'm going to start with my video. So first I access my module memory. So this is very basic. You have all the pages, you have all the registers that are implemented in your module. We have direct access to them. So here I just read 2 pages, and I'm just going to show you how clear everything is. So I read my data. This is a basic tab. We have this also on our module compliance boards. So as you can see here, we can see all the registers. An interesting part of the MSA table that we have added here is a read-only column. So all these boxes are checked as per CMIS. So any register that is supposedly read-only is checked here as per CMIS. But the addition that we added here is that we allowed you, based on your customization, so a lot of us are customizing our module memory now. So if you have a register that is writable, that by CMIS spec is supposed to be read-only, you have the chance to work with that register as you have implemented it. So here I just uncheck a read-only register and I write to it, and it effectively writes the new value that I write to it, treating this as a custom register. I'm going to move on to the MSA validation tab. So the MSA validation tab, I don't know if any of you have seen me at any of the shows that we've done, OFC or DesignCon. This is a tab that I'm always so excited to show because it really cuts down validating CMIS implementation by hours. Okay, so here what we do is we're validating against register access type and we're validating against register content. So what we're doing is we're validating, is your module memory, is this register supposed to be read-only, write-only, or read-write? We're validating your implementation against what it says in the CMIS spec. When it comes to register content validation, there are some registers that are bound by a certain range of values, which we also validate here. And so, literally, I just validated one page in less than 5 seconds, and it gave me a set of pass and fail registers. And it gives you a description of why one register fails against the other. So for example, register 26 from low memory fails because it's supposed to, we were unable to write to the register. And this register is supposedly writable. So this register, if I'm not mistaken, is to force module into low power, which we all need to be writable. So next, I'm going to move on to our next tab, which is the module emulation tab. Now you see here that I pull up another UI. So this is my host user interface. This is my module compliance board user interface. And I pull it up because I'm about to put Nexus in target mode. And when I put Nexus in target mode, it acts as a module and I control everything from my host, which is why I have this UI open, because now I want to move on to module emulation. And when I use module emulation, Nexus emulates a module memory to validate that my host is reading from or writing to whatever module memory correctly. So here I'm validating the operational side of the host. All right, so here I have Nexus, which is emulating a few pages of memory. I can add a few pages from here. And what I'm going to do is I'm going to write to some of these registers from Nexus, and then I'm going to validate those from the host UI. So I write on two registers, on register 128 from page 2, and I write on register 0 from low memory. So I'm going to write those, and then I'm going to read them from my host UI to validate that my host is effectively writing to the module memory. So I go to my host UI, I access the I2C read-write tab, and I start by reading register 120, register 0 from low memory, excuse me. And I should expect 19. There we go. And then I do the same exercise for register 128 of page 02, and I effectively read FF. I will wait until you guys can see that as well. So there we go. With this very simple step, I eliminated that any issue is coming from my host. Now I go to my control signal software access. So here I put my Nexus back in initiator mode. And here I show you in a second that when I put it in initiator mode, everything is like disregarded on my host UI, because now Nexus is acting as a host itself. So here what I want to do is I'm going to change the control signals from Nexus, and I need to know that my module is replying to those commands correctly. So I'm going to start my analog reading. And then I'm going to drive my low power signal high. And I see that change on the graph, effectively validating that my module is receiving that command well. And then I also do the same for reset. And I see the same change. So now I put them back to normal, and I'm going to proceed with my state machine tests. So the state machine tests are really at the core of CMIS, and I'm just going to take some time here to explain to you. So the state machine tests include module state machine test, they include data path state machine test, module behavior model, and the network path state machine test. So here I start with the DPSM test, which is the data path state machine test. Now, the box that you see that popped up here is very interesting because it allows you to override the CMIS timing limitations. So sometimes you try to drive your module from low power to high power, but it's unable to get to that because, or it goes to a fault because it's not complying with the CMIS time limitation of that specific state transition. So in order to validate your module functionality without really taking a look at time compliance or time and compliance, we allowed you to override the CMIS time limits. So which is something that I do here. So I override this DP turnoff. Actually, I think I override them all. Indeed, I do. So here I just want to validate that my module is able to transition from one state to another, or that my data path in the module is enabled correctly without really looking at the time and compliance. So as you can see, I'm validating it, it's manual, it's super clear. I have really structured, organized, clear logs next to me, which I can then export into a PDF report. So here I validated the data path of my module, and now I'm going to go to my module state machine test. And here I'm going to initialize my test. I'm going to try and abide by the CMIS time limitations. And I'm going to try to drive my module from reset to low power to module ready and back again. As you can see, I have first fault when I press on reset. And we're going to debug that together. So I repress on reset, it worked fine. I go back to module low power, I try and take it to module high power, it works great. I go back to reset, it goes to a fault. So here, I'm going to try and override the CMIS time limitation of my reset state. So I'm going to increase that time a little bit, and I'm going to reiterate my test to make sure that the functionality of my module is fine. I'm just not CMIS compliant yet. So as we can see, it's validated, everything is working fine. And now to a part of the webinar, or a part of Nexus that I really love, is the direct access to upsell code. This is really something that we have heard time and time again. It has been requested time and time again by people in the industry because we need it. With the complexity of new modules, we need something that allows us to accelerate module provisioning, and this is it. I love it because it shows you the supported upsell codes on your module. So you can see they're the first two highlighted. You can choose which upsell code to implement on your module. And then Nexus takes you a step further to validate the host test routine in implementing that upsell code. So not only do you have direct access to the module upsell code, not only can you implement a certain upsell code in a second without having to go into registers and all that really tedious procedure. You can just do it in 2 seconds here, but then it takes you a step further in validating that your host is correctly implementing the upsell code which you have selected on your module, which is the block diagram that you see here and the logs that you see on the right. I mean, it's lovely. I think it's lovely. I know some people that have used it think it's lovely. So yeah. So now I have shown you guys how well we can optimize the time of CMIS implementation validation. I mean, I did that. The video is 7 minutes long, and I took a little bit longer because I'm explaining, but it really can be pushed down to less than 10 minutes. Now we move on to analyzing I2C or validating I2C. So Not only do we need to validate the communication between host and module, but sometimes we want to validate the I2C protocol itself, which requires I2C packet capturing and I2C analysis. So we need to know which registers were involved in this operation. Or when did it start? When did it stop? What is the content in those registers which are involved in said operation? I'm going to show you guys all of this again through a video. So we're going to start with the very basic I2C read write tab, where I very simply read from my module memory and make sure I can write to it, check, validate it. Next, I2C analysis. I want to validate I have continuous communication between host and module. I want to validate I can trigger communication between host and module, and I want to see what happens when I trigger it upon a state transition, upon a low power signal. Now you'll see the options that we have. And finally, we have a very nice measurement tab, scope mode, which allows you to measure or to monitor two signals at once. So either SDA and SCL for I2C, or either VCC and current, VCC and SDA, you will see it as well. So first, we're going to start with the very basic I2C read write tab. I think any CMIS compliant product has this or has access to that. So here just I'm accessing register 26. I'm trying to force my module in low power mode. So this is just the CMIS spec, which you see here. This is not a part of the UI. So then I read from the module state register, and I effectively read that my module is in low power. So here I validated that I'm able to write to it, and my module is taking the right host command. Now I'm in I2C analysis. I love, love, love this tab because, again, we really built this tab taking into consideration so much feedback from people in the industry when it comes to validating the I2C protocol. So first, I'm monitoring the continuous communication between host and module. Are there any interruptions? Do I have communication at all? Yes, I do. And it looks like they're speaking fluently together. So this is check. Now, next, I want to show you guys. So here, I just want to skip these to show you guys a single packet capture. Because when I do a single packet capture, there we go. So here, I think I've captured about 5 or 6 packets. And now when I zoom into one of those packets, you see that we have access to the time. We know when each operation started, when each operation stopped, and then we have the binary data, which points to if it's a read or write operation, which register am I reading from or writing to, and what's the content inside those registers. And something super cool is that when I press on a packet in those beautiful packet details, it takes me to that specific packet on the graph. When I press on an ACNAC, it takes me to that specific operation on the graph. When I press on a certain binary or on a certain a chunk of the register, it takes me to that on the graph. So it perfectly positions you on the graph to do the analysis as you see fit. So this is great, and I'm really emphasizing this because, again, we've seen this need in the industry. We've seen our customers struggle in labs or in data center environments because they don't have this many details when it comes to the I2C communication. They don't have all the details that they may require for certain application or to validate the I2C protocol itself. Now I'm going to move forward still with the I2C tab to a very nice feature, which is triggered I2C. So this again, I mean, for those of you who know us, know that we have a previous generation of analyzers, and it also had I2C analysis capabilities, but the amount of customers that we had that really wanted us to implement the ability to trigger the I2C communication and to analyze it based on whatever operation you trigger, this one's for you. Okay, so this is triggered I2C. So now what I'm going to do is I'm going to put my Nexus in bypass mode, and I'm going to put it in bypass mode because I want to trigger the communication from the host side. So effectively, I pull up my host UI, as you can see on the right side of my screen, and here on Nexus, I'm configuring Nexus to trigger the I2C based on a control signal. So I'm choosing control signal trigger, and I'm choosing the low power control signal. As you can tell, this is one of my favorite control signals since I used it to demonstrate quite some features. So I'm going to try and trigger that communication. So I'm going to go from my host side, my low power signal. I'm going to drive it from low to high, and I'm going to see that communication on the graph. So here I effectively captured 4 packets of data. Lovely. And then you just have access to the same packet details that you just saw a few moments ago. There we go. So 4 packets, press on any packet you want to analyze, check which registers are involved, what is the contents involved, when does each operation start, etc. By the way, every time you see a graph on the screen, all the data on the graph can be exported. Okay, so all of this can be exported, shown to your team leads, shown to anybody that requires it, and it has all the details on them. The packet details can also be exported. All right, so this is just, we really wanted to build a tool that simplifies the day-to-day workflow of firmware engineers, test and validation engineers, field application engineers, and we really wanted it to be a tool that minimizes the risk of error. All of this used to be manual, all of this used to be very time consuming, and now it's not. So I'm going to move on to the last part of validating I2C, which is scope mode. So in scope mode, I'm going to put my Nexus in bypass mode again, or I keep it in bypass mode. I'm going to configure it, and what I'm going to do is I'm going to get SDA, or I think VCC and SDA, and I'm going to monitor those together. So I'm going to monitor the VCC supply on my module, and I'm going to validate that there is communication between host and module. So as you can see, my module is receiving enough voltage, and there is communication between host and module. I'm going to move on from here. So this is just a reminder before moving on that you guys can send your questions on the Q&A box before we get to the end of the webinar, or you can save it until the end of the webinar. We will have some time to answer any question, okay? So now we went over the most time-consuming part of CMIS implementation validation. We went over validating and analyzing I2C communication between host and module. And now we're going to go over something that we have to do every day as engineers, which is debugging. Debugging everything from the cable to the module, to the host itself, to the communication, and then generating a report and presenting that to the team and trying to come up with a solution. I mean, my God, just even remembering these situations or seeing the frustration, not just internally on us, but on our customers, makes me really, really proud to have been involved in developing such an innovative tool. So using Nexus as a debugging tool. So I'm going to show you a set of 3 applications. Okay, so the first one is bringing up a module. So module bring up issues are very common in the industry today. They have always been, but now just the variety of modules that we have to account for, we've seen a rise in module bring up issues, all right? So here the basics we take to effectively bring up a module, and I'm going to be bringing up a golden unit. So I'm going to bring up this module with no issue whatsoever. I just want to show you that we've automated a series of tests that really combines the module bring up sequence into a really short time and in a really effective and straightforward manner. So here I'm using Nexus and Initiator. I'm going to go over module VCC supply. I'm going to check input-output signals. I'm going to do some state machine tests. You've seen these before in the webinar. You're going to see them again for a different objective. So we're going to start with validating that there's enough VCC or there's enough voltage, or we're validating the module power-up circuit, the module bring-up circuit. I will need to make sure that there's enough voltage going to my module. So this is very simple, a very straightforward tab. I'm just going to measure the continuous VCC supply. And as we can see, my module has more than enough supply to be brought up effectively or correctly with no issues. Next, I'm going to access control signals. So here, by the way, I recorded this by using a different form factor. As you can see, the control signals have differed here. So here we're using QTT, and I just do the very basic test of the same one that I showed you to make sure my module is reciprocating the host commands correctly or answering the host commands correctly. Next, I put it in bypass mode. I tap into the communication between host and module. I can analyze it if I choose to. Here, I'm not going to. I'm just going to validate that there is continuous communication between host and module. Since we've already seen this, I'm going to go over it. So I have communication, no interruption. It looks beautiful, great. I'm going to move on. Very simple read-write tab, which we have already seen. So again, here I want to make sure I'm able to read from my module, I'm able to write to it. So I'm trying to read the module state, and then I try to write to the same registers again. Okay, so now I'm going to move on to the monitor tab. So this is the first time you guys see this in the webinar. This is a very, oh, excuse me. I wanted to pause, but I went to the beginning. So this is a very comprehensive monitoring tab, which I also really love to use and I love to demonstrate because it allows you to monitor the module temperature, the module VCC supply, the module current, as well as the TX power output, as you can see here. We will also have the ability to control that TX power output through the GUI directly, and we've demonstrated that actually with OIF, with the Optical Internetworking Forum a few months ago at the ECOC. So this is the digital monitoring tab. We also have a versatile diagnostic monitoring tab, okay, which I don't show in the webinar. So again, I do some state machine tests to effectively bring my module to high power mode as I think a last step in this application. So I override my CMIS limits because I'm not trying to comply to the CMIS time limitations again yet. I'm just trying to validate the module functionality, which I do. So I reset it. I go to low power, and then I take it to high power. And this is great. And you know, I really love the state machine tests because they have helped me debug some of our setups. And once we were working on a setup with a high power mode transceiver, and the transceiver was not being brought up correctly. And so we ran a state machine test to see what exactly is going on. And it was showing us that the module was being stuck in the module power up state. So the module was going out of module low power, but it was not going into high power mode. It was stuck here. I'm going to continue that story shortly, but just to show you the benefit of state machine tests. So here I'm going to move on to high inrush current or just inrush current measurement. So inrush current measurements are highly effective in modern data centers because it shows you whether or not your module has a large input capacitance, and it accelerates module host bring up issues. It accelerates solving module bring up issues on the host side. Okay, so first I'm going to show you guys. So here we measure the inrush current of a module with an intentionally defective capacitor. So I just want to show you the high inrush current that we see here. So here I'm detecting inrush current upon module power up, okay? And so basically what I just want to tell you a little bit. Basically how this works is when I have a Nexus plugged into my host, I unplug my transceiver, I start my measurement, and then I plug in my transceiver, and that is the current that I'm measuring. It's upon module power up, okay? So as you can see here, my module is almost 10 amps. My inrush current is almost at 10 amps, which is crazy. It's really high inrush current, I suppose. And here I just show you guys the markers to again. So here exactly we're at 9.4 amps of inrush current. And I really wanted to just show you guys the markers to show you again how detail oriented we are and how much of the time and the frustration we took from you. And so this is the high inrush current. Now, just based on the CMIS spec or based on the MSA spec, this is the inrush current, or this is the peak current that we are measuring, okay? So it's this instantaneous current upon a module power up. So now I'm going to compare it with a golden unit module. I'm going to show you guys the regular inrush current, or the inrush current we should be expecting, or what is considered functional, I suppose. So here again, I do the same test and I measure the inrush current. First, I put it back in initiator mode. I measure it and I get about 1.5 amps of current. So there we go. Here you can see just the difference and how important it is to go through this step to really help debug your module functionality, or really help debug your module design. So again, here I just show you guys the marker, which I'm not gonna stick to now. So I'm going to move on to our last application, which is measuring C and current spikes when module goes from low to high power. So the story that I was telling you guys 2 applications ago about a module being stuck in module power up mode. So we were effectively taking the module out of module low power, but we were unable to drive the module to high power mode. Once we saw that it was stuck in module power up, we wanted to debug further and see, why. And when we measured the VCC supply on the module, we noticed that when we're taking it out of low power mode and into high power mode, there is a significant voltage drop that is not allowing the module to go to high power mode. So here, basically, I wanted to replicate that and show you guys what happens, or how we can monitor what is happening when we are transitioning from one state to another to voltage and current. So here we go. I'm going to start with scope mode because we already went over that in scope mode. You can measure several signals at once. So here, obviously, I'm going to pick voltage and current. And then I also pull up my CMIS host UI to drive my low power signal from there. So I'm going to drive it from low to high. And in real time, you can see exactly what's happening. Now, I would like to also emphasize that we are analyzing, we are debugging, and we are seeing the results in real time. So this is great. We're not waiting for anything. We're not waiting for a certain tool. This is really results in real time. As you are sending commands from the host, as you are measuring a certain signal. So again, here you can see a significant voltage drop and a small current spike. So sometimes voltage drops can really affect high power modules going into high power mode, and you need to compensate for the drop. But again, compensating for the voltage can sometimes be dangerous if there is no voltage drop, which is again why we need a measurement tool to do that. So this is also minimizing the risk of error. This is also taking it out of our hands and automating it instead of it being manual, instead of us just probing at the correct sensors and somebody looking at the screen, somebody probing, etc. So This is the Nexus roadmap in front of you. So this is just to say that Nexus currently supports CMIS 5, which is what I based the screen recordings upon, but we are also preparing for the release of coherent CMIS support. This should be available after OFC, and we have a few cool demos with the Ethernet Alliance showing our coherent CMIS support. And then we are also prepping for the CMIS 5.2 support coming out soon. So far we have covered that, we can really take the manual, the time-consuming, the frustrating and mundane testing procedure of seamless implementation validation and of full system interoperability validation and really automate that and minimize the risk of error. And our biggest thing is showing you guys that we don't need to have a full understanding of CMIS. Whenever I talk to anybody in the industry about CMIS, we scratch our heads and they're like, oh, it's so complicated, it's so complex. It's really not. CMIS aims to simplify, but we also understand that, when you just want to validate your module design or you just want to validate the CMIS implementation on your host or your module, you don't really want to go into 350 pages of standards. 350 pages of standards. And, we're telling you guys, we have it covered. We want to take this responsibility out of your hands and put it in ours. And, we want the trust that you're going to get the correct reports, you're going to get very clear-cut answers, and you're going to validate CMIS seamlessly. So, yes, thank you.
Test farther, deploy faster with MultiLane.